disappoint you. Today we will have one more example in terms of constructing a confidence interval. On Friday, we talked about constructing a confidence interval with a sample proportion. Today, we'll look at doing that with a sample mean. And I picked the example question pretty specifically because I really suspect that you're going to be asked on one or the other, maybe both of the questions. You're going to be asked to make a decision or make a recommendation based on your result. And ultimately, in the real world, that's what you do with regard to statistics anyway. You do statistics in order to make decisions. And so I think that's really ultimately what's going to happen is you'll see a question like what we're going to walk through today, where you have to make a decision or make a recommendation based on your result. So let me go ahead and put the question up on the screen. I will send this to you after we're done so that you can review it if you want. And I will also send your exercise, I guess your assignment for the day after we're done here as well. So we're going to look at a question from the 2008 exam, and it's question number 3. A car manufacturer is interested in conducting a study to estimate the mean stopping distance for a new type of brakes when used in a car that's traveling 60 miles an hour. The brakes will be installed on cars of the same model, and the stopping distance will be observed. The cost of each observation. So every time you run the test, it's $100. You have a budget of $12,000 for the study, and the goal is to carry it out in the most economical way possible. And based on our preliminary studies, we think that the standard deviation for stopping distance is 12 feet. So the first question is, are there sufficient funds available to estimate the stopping distance within 2 feet of the true mean stopping distance with 95% confidence interval? Okay, so there's a lot of information in that question right there. Is there enough money to do the testing to estimate the stopping distance within 2 feet of the true mean? Now, the cool thing about this confidence interval is we really, at this point, we don't have to know what the mean stopping distance is. In fact, we've not been told that. And so we're really not calculating a confidence interval in this particular question. The thing we're working on here is can we meet the regulatory requirement within budget? And this is a really real world situation. In my experience, both in the military and in industry, these are the things that you run into every day in terms of using statistics. You've got constraints that prevent you from doing whatever you think you need to do, and you have to find a way to live within those constraints. And so far right now, one constraint is we have a budget of $12,000 that we cannot go over. And the other constraint is we have to meet the federal regulations. I mean, you can't install a new brake design on a vehicle without passing all the regulatory requirements, which is important. I mean, someday you may find yourself riding in a car with Gracie Wharton and you want to make sure the brakes don't fail. So, I'm just saying. So let's get into the real question for right now. Are sufficient funds available to estimate the mean stopping distance? Okay, so the question here is really how many tests can we run? How many observations, they call it, can we run? And will that allow us to estimate within 2 feet? Okay, so in the language of the question here, estimate within 2 feet of the true mean. What we're talking about here really is a margin of error. Can we figure this out with a margin of error of plus or minus 2 feet? And so that calls into mind the margin of error question, which I'll go ahead and flip on the camera now. I think we should be able to see. Okay, so if you remember, the margin of error inequality is that our margin of error has to be greater than the z-score, the critical value, times the standard error. And for a sampling distribution of sample means, that's the standard deviation over the square root of n. And so now you see why in the problem statement, they had to give us this value. If that value wasn't given to us, if it wasn't given to us right here, that a preliminary study, and my guess is in the auto industry, that preliminary study is some sort of computer model that they've done, which is routinely done, and those computer modeling systems are really quite advanced and pretty accurate in my experience. So we did our models on the computer. We came up with some mean plus a standard deviation of 12 feet. And so we're going to use that. We're going to use that to get us in the door here with our calculations. So the margin of error here is 2 feet, which needs to be greater than the z-score, and we want 95% confidence. So that implies that Z star is 1.96. And I didn't plan very well, so I almost ran out off my board there, 1.96. So 1.96 times the standard deviation, which was 12 feet, divided by the square root of n. So now this exercise becomes really just a measure of a little bit of algebra here to rearrange and solve. I want to get n by itself, so I'm going to multiply both sides by the square root of n, and at the same time I'm going to divide by 2. So I end up with the square root of n is greater than 1.96 times 12 divided by 2. Now to solve for that, I'm going to square both sides, so n now has to be greater than 1.96 times 12 divided by 2 quantity squared. And for those of you who remember in Algebra 2, every time I undo a square root by squaring, I have to think about this plus or minus, right? But in this case, we can ignore the negative one because it doesn't make any sense to have negative observations. So, and on the exam, you don't have to worry. You don't have to worry about that. Just go ahead and square it. Don't worry about the plus and minus because there's no way for us to have negative observations. So when we do the arithmetic here, we come up with a value of 138.3 observations. Well, we can't have 0.3, so n has to be greater than 139 trials or observations. So the question, if you remember, the question is, do we have enough money to do the study? And to To answer that question, we take into account the budget, and the budget was $12,000 divided by what was it, $100 per trial, and that tells us that we can only do 120 trials and still stay within budget. And I see there's a glare there. Let me move that around. There we go. Okay, so the answer is I have money to do 120, but to meet the regulatory requirements, I have to do more than 120. So the answer to the question is no. I think, let's see, let me go back to the question again. The question are sufficient funds to estimate within 2 feet with 95% confidence interval? No. Need to do at least 139 trials or observations. Okay. So now we're stuck. We're stuck between the hammer and the anvil. The auto company, my boss, wants to get this new brake system on vehicles as quickly as possible. Federal government says you got to do the testing, and your accountant says you can only do $12,000 worth of tests. And so that's what the next question is all about. We're required to have a 95% confidence level to estimate within 2 feet. We can't exceed our budget, and so we want to discuss the consequences. So let's talk about that. I want to hear from you what you think. What would you do? How would you respond to that? You tell me. How would you answer that question? Any ideas? Well, what could we do? We can't do all 139 trials. We can only do 120. And so if we stop at 120, what does that do? What changes if we stop at 120? What requirement can we not meet? Well, let's go back to our formula. Let me put this back on the screen real quick. Let's go back to our formula here that we had at the very beginning. So here's our governing equation. This value can't change. Z star is based on 95% confidence. To meet the government requirement of 95% confidence, this number has to change.
Is this supposed to be on screen?
It's supposed to be. Oh, I forgot to share it. Thank you for reminding me. I don't know who said that, but thank you. Now you should be able to see it. How's that? Can you see that on the screen now? Okay. So Z star can't change because we've got to meet 95% confidence. The standard deviation, I suppose we could go back and redo the trials and redo the computer models. And quite honestly, if I were the program director in an automotive company for this is one of the things that I would go back and do is say, hey, can we sharpen our pencil and reduce this value a little bit more so that we can get to get to where we need to be. But let's suppose we can't do that. Then within being 120, being if this number is less than what we need, then our margin of error is going to go up. So if this number goes down, because it's in the denominator, then what goes over here has to go up. And so the margin of error will increase. And so you might, as part of your response to part B, it might be a good idea to see what is the margin of error when when I conduct 120 trials. And so I'll tell you what, I'll just flip this over here, and I think we'll be able to see. Let me clean that off. See if I can. So what will the margin of error be if n is equal to 120? So 1.96 stays the same, 12 stays the same, and I just plug in 120 here. And if I do the calculation, the margin of error will turn out to be 2.15 feet. Okay. And so just for calibration's sake, that is 2 inches, roughly 2 inches. It's a little bit less than 2 inches, but roughly 2 inches. In other words, it is the space, since I flipped this grid over, I think these are 1/4 inch grids. So 1, 2, 3, 4, 1, 2, 3. They must be 1/2 inch mark. So here's 1, here's 2. That's the distance we're talking about in our margin of error. And if you're stopping a car at 60 miles an hour, what does it mean that you increase this margin of error by 2 inches? Well, I guess to the federal government, it means a whole lot. I mean, theoretically, the number of accidents could go up because the stopping distance was, increased by 2 inches. So that's the concern. And so how would we answer that? I'm curious. What would you say? What would you say? How would you answer part B? Just give me a wild guess. Let's look quickly at the question again. Question is, discuss the consequences of these constraints. So what would we say? Well, like I said at the beginning of this, I don't think I need this anymore. Like I said at the beginning of this, we're really between a rock and a hard place. And the bottom line is the consequence of these constraints is that the federal regulation and the budget cannot be met at the same time. So that's the consequence. The minimum margin of error that can be achieved with 95% confidence and 120 observations is 2.1 feet. And so we can't meet the consequences. But in the real world, you can't live with that answer. You have to come up with some way to go and figure out how to handle these. Now, this is beyond the scope of this question. This really comes down to, I have had exactly these kinds of discussions before. How do we get this done so that this product can go on a vehicle? And it becomes incumbent in a way, most likely what you're going to be told is go figure out how to reduce the cost of the test. so that, you can do 139 tests instead of 120. I don't know, just figure out how to reduce the cost and get it done, because we're not going to let this new product go untested or unapproved by literally a matter of 2 inches. And the government's not going to change. You're not going to go talk to the government. You're not going to have any luck saying, well, it's only 2 inches. Nope, they're not going to buy that one bit. They're not going to. Now, one thing you could try to argue is, can we come off of the 95% confidence level? Remember, if we reduce the confidence level, then the margin of error increases. So could we live with 90% confidence, or, for crying out loud, maybe 93% confidence? That might get you enough. But the federal government's answer to that question is no, I have to have 95% confidence. So the bottom line is, the two things that you can work with that are under your control if you were an automotive engineer would be the cost of the test or the accuracy of the computer model. You might go back and say, can we change that? So I really, really, really do expect a type of question similar to this on the exam. And I will send this to you so you can have it in front of you and look over it, go back to it again at some point. But I do expect that you'll be asked to a question like Part B in the example. So we need to think along those terms. So let me show you the question I want you to work on today after we get done here. This one comes from the 2009 exam, and it deals with the confidence interval of sample means. And I selected this one for a very, very important reason, because it deals with the difference between two means and not just the mean itself. So I'm going to give you a couple of hints just to refresh your memory on how we handle combining random variables. So let's talk about the question. So there are two fire stations in town, one on the north side of town, the other on the south side of town. And the city council is in a debate as to which of the two fire stations have a better response time. So we collect data to kind of answer the question. We took a random sample of 50 calls from the northern fire station, and we found that the mean response time was 4.3 minutes with a standard deviation of 3.7. A random sample of 50 calls from the southern fire station had a mean response time of 5.3 minutes and a standard deviation of 3.2. So based on that, let's construct and interpret a 95% confidence interval for the mean response time. Okay, so what you're going to end up doing here is you're going to create a random variable D that represents the difference between the two fire stations. Okay, so let's get that on the screen here. Okay, so I'm going to say that the mean mu n is the mean time for the north fire station, north response time. Oops, I got to be sharing this again, don't I? What a silly goose. There we go. Now you should be able to see my whiteboard here. The north response time is mu n. Mu s is the south response time. And I'm going to call D the difference. The difference in the means. And when I do that, I'm going to be smart about how I do this because I want to deal, whoops, right here. I want to deal with a positive number. So the southern fire station has a longer one. So I'm just going to call it mu S minus mu N. Now, ultimately, it doesn't make a difference. It doesn't make a difference which difference you take, but it just makes the arithmetic a little bit easier if you do the south minus the north, okay? So now that's an easy value to calculate, and you're gonna construct a 95% confidence interval. Remember our the general equation here is an estimate plus or minus the critical value times the standard deviation of the statistic. Okay, so now I'm going to give you a warning. Your estimator, your point estimator will be D, plus or minus critical value you've probably already figured out. This guy here. Remember, and I'm just going to ask this question, what happens to measures of spread when you combine random variables? I'm going to leave it at that. If you don't remember off the top of your head, you go back and you got your textbook in front of you. Go back and refresh your memory about combining standard deviations. When you combine the means, all we have to do is subtract the two, but there's something important when we combine standard deviations. So I picked this question again specifically to refresh our memory about what to do there. And let's see, the rest of the question, does the confidence interval support the member's belief? Okay, so the one hint I'll give you here, and I think I can turn off the camera. The one hint I'll give here is if the train stations, if their response times are the same, what do you expect the difference to be? If they're the same value, what do you expect the difference to be? And does the confidence interval you construct contain that value? And so I'll leave you with those two hints. If you still are stuck, feel free to contact me. I'll be glad to answer any questions. Okay. Tomorrow, kind of a big day for us tomorrow. We're going to start looking at conducting inference tests, and this really is the holy grail of this course in statistics. Can we begin to make inferences about populations? In other words, can we say something is true about a population or not? And that whole process is called significance testing. There will certainly be a question on the exam that requires you to if not do a significance test, certainly interpret it. Now, when we get into this, significant tests, they take a fair amount of time, even for somebody like an instructor like me who knows what we're doing. These tests take a few minutes, and your time is extremely limited on this test, and so and you're also only going to be given access to, or only expected to have access to, a 4-function calculator. So I'm not sure that you'll do a full-blown significance test on the exam, because quite honestly, you'll see this week as we go through examples, it takes 25 minutes for us to go through this process. But I know, I don't have any doubt on one or both of the questions. You'll have to at least interpret a response or finish something about the test, or be able to discuss type 1 and type 2 error. This is where, all year long I've been talking to you about the water keeps getting deeper and deeper and deeper. Well, beginning tomorrow, we're going to step into chest deep water that's up to here. Now, it's not going to go over our head. We're capable of this. I'm confident that you guys are capable of handling it. But it's a challenge. It takes some time to let this stuff soak in. And so my plan is, we're going to take the rest of this week. We'll talk about significance tests. I'm not calling anybody out here, but hopefully you'll be able to finish your AP Lit work by the end of the week too, and you'll have some time after this week to do a little more thinking. Trust me, I know what you're going through in AP Lit. I've got one just down the hall here from me that is going through the same thing, and I get it, guys. I really do. So hopefully after that's all said and done, you'll have a little bit more time to think through this. And at this point, I'm really glad you have your textbooks at your fingertips. I'm going to switch my mode of instruction a bit. Normally I would, show you notes and things like that from my smartboard, but there's so much information here. I'm just going to use prepared PowerPoint slides that come directly from your textbook. So honestly, you're probably going to want to have your textbook open as we go through our discussion. And there's there's a lot of terminology we got to cut through in the first couple of days. So don't be intimidated. Don't be overwhelmed. I will not let the water get over your head here. We will, but it's going to get deep. So bring your swim wings if you need to. But we'll get through it. We'll take this week, maybe a day next week. Then we're going to step back from this. We're going to let this soak in. We're going to cover one simple, after this discussion, you'll be so glad that we're talking about regression analysis, because it will seem so easy. We'll take a few days, cover regression analysis, and then we'll come back to this after we've had a chance to let this soak in. So that's my word of encouragement to you. This is really the ultimate reason for taking this course, and it's like I said, it's the Holy Grail. Just stay with me. I will get you through it, but eat breakfast before you join, because if you've never been through this, it's a bit it's a bit confusing, but we can get through it. I got through it. You'll get through it. We'll be fine. And I really, really, really anticipate the question on the regular exam, and we're going to go through several of those exam questions, and you'll see how rigorous they are. And honestly, I don't think you'll have time to do all of that on this test. So in that regard, I think you'll I don't think you'll get off easier. I just don't think you'll have to do as much calculation. I think it'll be more about interpreting results. And so that's going to be my direction. Okay. So you'll hang in there. Just be prepared. This will be the most challenging part of the whole course. But the good news is we've got plenty of time to get through it and throw in a review before test day. Okay. Any questions before we sign off? All righty. Well, let's see.
What is the NTI assignment for today? Is that the second thing?
Yeah, the one about the fire stations. Yeah, I'm sending that. I'll be sending that here in a few minutes when the video downloads. I'll be sending that, and well, I can go ahead and send it to you now. And the video will come it takes a while for the video to process, but I'll go ahead and send the assignment now. You can have it. You can start looking at it while it's fresh on your mind. All right.
Okay.
I'll hang in there, and I look forward to seeing you tomorrow. Take care.
Bye.
Bye.
Bye-bye.